Well, thanks for listening in to Remoting Performance Smackdown. That's how Alex called it. Benny and myself, we spent quite some time in the past years, actually, in this topic, and we'll share 30 minutes, 40 minutes of great content we got into the past months. My name is Ruben. I'm the CTO for Attendance Computing, and as you know, active in the community on many levels as well.
Hi, Benny.
Easy. You saw the Team RGE logo earlier, and Team RGE is a great group of awesome people, as you can see here. Awesome people, Frank is there as well. And the goal of this group is to create new content, create awesome content around GPUs and application remoting, and share that content. White papers, blogs, presentations like this, and a lot of videos as well. The group started with 3 guys, Sean Bass, Benny and myself, and we expanded this group in the past 6 to 7 months. I think it's also an interesting call to action. If you're deep into GPU and application remoting and potentially are interested in joining this group, let us know. We are happy to have a conversation about, okay, what do we expect, what can you do, where can you contribute. So if you're interested, or if you're listening in later and interested, just reach out to us. I'm happy to have that conversation with you. We'll have 3 topics in this around 30-40 minute session around Windows, GPUs, and GPU options. How to benchmark. It's interesting to know how we do benchmarking, so hopefully you can pick up some great info for that. Maybe you can use it in for your own environment around benchmarking, what kind of tools we use, how our lab environments will look like, these kind of things. And then we spend around 50% of the time around the videos we created. I created in the past 2 weeks, around 250 videos. Benny did the same, and we selected 10 scenarios, 10 sets of videos, and we'll showcase these videos with you. If you have questions around other scenarios, just let us know. There's much more to share, but we have just 30-40 minutes for now. So. Interesting question. When you look at the panel discussion as well, we pick it up a little bit, like, hey, in cloud first and mobile first, is Windows remoting still relevant? And why do we need GPUs? Is also an interesting question. Well, that's a question, a simple answer, because Windows everywhere is dead. And when I made this comment yesterday and 2 days ago as well on stage, a large audience, some people were like, I'm not sure this is true. So let's do the poll here as well. Who is using a Windows phone besides Benny? I know Benny is using a Windows phone. Who's using a Windows phone?
What's that?
Gave it up 2 years ago.
Where is Joe Harder when they need her?
So that's my simple conclusion why this statement is accurate. Because Windows everywhere, as it was like 5 years ago, 10 years ago, isn't there anymore. Doesn't mean that Microsoft isn't there. Microsoft everywhere isn't right, but Windows everywhere is not the case today. But Windows itself is not that, and I've proved to showcase and to explain that. One of the proof points is this one. In the past 3-4 years, we surveyed around 1,000 people in the industry. 1,000 people filled in the survey. Companies filled in the survey, indeed. And one of the questions, one of the 50-60 questions was, what is the percentage of applications you're using in your organization, or what are the native applications in your organization? Funny, interesting to see is that you see that there's an increase in Windows application in people are using in their organizations. And VDI Like a Pro, that's the community program, community companies where we launched this survey. We surveyed around the people who filled in the survey, around 600 people, so a reasonable number of people. And you can download this great survey from VDILikeAPro.com. So if you go to VDILikeAPro.com, you will find this survey and very interesting results around this question in particular, or hypervisor-related question, or application visualization, or layering, or GPU-related. There's a ton of great info in this survey. And what's also interesting is that we can correlate this type of question with the other questions and the other years we use this survey, 14, 15, and 17 as an example. Connected to GPU, so Windows is relevant in our space. It will be relevant for the next 5, maybe 10 years. Is it the only thing which is relevant? No. There are many other things. Besides cloud and mobile, maybe other stuff in 5 years from now, which is more relevant. Look at AR, look at mixed reality as an example. Connected to GPUs, this is quite often connected to like high-end GPUs. Although I'm not a designer like here, I know some folks in the audience are. I like to play games, so that is heavily GPU related as well, especially these days. But we all in this audience leverage GPUs. And the baseline is GPU, for 2 reasons. The baseline, look at all the laptops here, Ultrabooks here, Surface Pro, Surface Books here. They have 2 things in common. It's GPU, they all have a GPU, and quite often a powerful GPU as well, and they have flash. So that's the first angle. So the baseline is GPU and flash. And now we design or redesign server-based computing or VDI, on-premises or cloud, quite often without GPUs and with like a crappy storage performance. That's not the right starting point. And the second baseline is the developer itself. When he or she is developing software, she's not developing the software in VDI or in server-based computing environments on-premise or cloud. No, it's being developed on their own laptops, their own workstation, their own desktops, which has a GPU. So for them, it's just a normal thing that the GPU is inside. That's why GPUs are very relevant also in our space. Interesting question is how much video frame buffer do you use? And you can measure it yourself if you download a simple tool called GPU-Z. You can see how much VRAM you're using. And this is a screenshot I took a couple of months ago, just in my simple environment. I'm not playing a game here, it's just Office, working on a couple of presentations, using Outlook, running Slack and Spotify, my normal app stack. And I'm using 728 megabytes of video RAM in this setup. What if I'm using this set of applications in a virtual environment and I don't have a GPU with this kind of things? Then my CPU tries to do its best in, well, doing these tasks. And that has impact on scalability, it has impact on user experience. That shouldn't be rocket science for most of the people in the audience. But it's good to explain just by showcasing these kind of pictures that, hey, it is relevant to think about these things. Interesting is there, and that's good, I like competition. Competition is great. Competition drives innovation, and I think that's what we need in the industry. That's good for us. I like innovation. I think everyone in this audience likes innovation. And it's good to see that there's more competition in this space. While NVIDIA is leading the pack in the GPU space, it's great to see AMD and Intel entering this space as well, and also competing with AMD in this space as well. Why? Innovation drives up new functions, new features. Look at what's just being announced at Synergy as an example. But also discussion about licensing cost, and cost in general is a good thing when you have more people in the same space, right? And that's what's needed right now, because NVIDIA is leading, they are king of the hill. It's good to have well, more competition in that space. When we look at what AMD and Intel and NVIDIA are offering, you can see it here. Multi-user GPU, we'll use that in the videos we will showcase. We have an AMD Fire Pro with MX GPU, so multi-user GPU running on Zen Server 7.2. An earlier version we received from Davis and drivers from the NVIDIA team. We're also using an
AMD team.
AMD team, yeah. Sorry, AMD team, not NVIDIA team.
That explains
makes sense.
No myths.
You know those bugs you reported?
Yeah, exactly.
I understand now.
The Intel one is the white label machine we received from Intel. So we use that one. We use the bare metal machine, in particular in this scenario, running Windows 10. Next week or the week after, we'll do the same with that machine and using Zen server-based computing type of workload. And the NVIDIA, we are both using Zen server and ESX on Dell R730. We both have a similar lab environment. So the gear Benny is using and the gear I'm using is almost identical. There are some small things like this white label Intel machine is what I have at home right now. But for the rest, Benny has the same setup. And that's important so we can, if I see interesting things or strange things, then we can correlate, we can connect it to each other. Like, hey, can you rerun this test? Do you see the same things? And that's important when you do benchmarking. And of course, on the NVIDIA side, we use M60 and M10s in our environments, and M6000 as a baseline to compare like local performance as well. One of the other questions NVIDIA like the Pro was, or is, do you use GPUs or offloading technologies in your environment? Why offloading? Because Teralisi is much more an offloading technology, not a GPU technology. That's why we have this question, and we want to capture both Teralisi type solutions and GPU solutions. It's interesting that the biggest competitor is not AMD versus Intel versus NVIDIA, but it's actually the CPU. People are using no GPU in the context of VDI and server-based computing. While that is declining, that is still the majority of people in our space. And NVIDIA Grid, in particular, is growing. It's not a hockey stick effect yet, but it's good to see that the numbers are increasing. AMD is still, although maybe they're doubling or tripling but that is easy. It's like 0.1% or 0.2% to go to 0.6% or 0.8%, but that's still small compared to the others. That's a pity. I really like AMD, and it's good, as I mentioned earlier, to have more competition in this space. But this is the reality. Intel is not there at all yet.
Were there no Teralisi responses?
There are some Teralisi responses, but it's not filtered, not in this particular this diagram. There's not a diagram with all the responses, and Teralisi was there as well. Yeah. That's in the white paper again, VDI@pro.com. You'll get that white paper for free. Just fill in the email address, so we can use your email address to contact you next year when we do a survey again. Proof to you that you're actually here.
I love this marketing.
I picked up a couple of screenshots on the AMD MX GPU and Zen server side. It's tech preview or early preview. The Zen server side is available since yesterday is what I picked up data. But the AMD MX GPU is not included in that, so if you have FirePro S7000 or 750 X2 device and you want to play around with AMD, let us know. I can help you with connections to AMD.
Well, the early access.
Oh, okay. I thought you were telling me I need to give you AMD drive.
No, that's not going to work.
No. Well, NVIDIA the AMD drivers from AMD. Thank you for all the early bits.
It's also interesting to see that both AMD here and NVIDIA are running in the same environment. So they're not supported.
Did you have to put an RPM and an RPM?
Yeah.
To do two?
Yeah.
Okay.
It's not supported, and I get some crazy things as well, to be honest. But it looks nice right now, and it's great to see brothers in arms in the same slide here. This is how you configure it on VM level. So you create your profile virtual functions on the AMD side, this side, 2, 4, 8, 10, 16. So we use the 8. So 8 like virtual functions per GPU.
Yeah, but they're inverse from us, right? So we say 8Q is an 8.
Yeah,
profile.
the numbers
they
have,
say 8 is.
Their numbers are much better than NVIDIA numbers are. No, kidding. This number 8 is nothing to do with the NVIDIA number 8. Nothing to do with that. This number 8, just to make it simple, is 1 gig of video RAM, and we picked for the same comparison also 1 gig. So the 1Q profile on the NVIDIA side.
You use a 1Q profile with us and an 8.
And the 8 profile on the AMD side. To have it as comparable as possible. Why the 1 gig? Because I showcased earlier the 728 or 24 megabyte of video RAM. In Win 10, don't start with a 512 meg video RAM profile. That is not going to work. That gives you some issues anyway, but that's not going to work in this setup. So 1 gig is what you need, and that's why we configure the AMD as well.
So if I have to do 2 gig, how do you do that in AMD? If I have to do
4.
AMD would go 4.
Yep.
4 sessions per GPU.
Okay.
With a total of 8 gig of RAM. So, 2 gig each.
Yep.
Okay, here it is.
Yep.
Thank you for asking.
So that's how you configure it. So it's integrated in Zen Center. He's upgraded the Zen Center, which is part of Zen Server 7.2 as well. And then you can install the drivers similar to NVIDIA. and you can configure it. In the early days, you need to configure it from the command line, but now you can configure it in the Zen sensor GUI.
Did you try any, like starting and stopping on another host with the AMD stuff? Can you move?
Yeah, but not like migrate. So
Not like migrate,
No, no.
but can you start on one host, shut it down, and then start it on the other? Or do you have to?
I didn't test it, but the question is, can you start it on one host, shut it down, and move it to another host and start again? I think so, but I'm not sure. I didn't test it. I assume, otherwise,
Does David know?
I don't know.
Yeah, I mean, if you mean, can you shut it down and then start it somewhere else?
Yeah, or do you
Yes.
have to reassign a new virtual function on the new host?
I don't think
I
so.
am 99% sure that you can just start it up again.
Yeah.
Okay.
Put it this way.
I would say I would like to test it, but I have just one R730 at home, and that's according to my wife enough. So, I can test that. But
So,
yeah.
Jared, if that does not work, it is a straight bug and we will fix it.
It's supposed to work.
Yes,
Yeah.
absolutely it's supposed to work.
Yeah.
Thank you.
He's gonna come back. In one way or the other.
Is Alex here? You guys still going?
Good. So, I'm gonna take it from here, and walking you through our lab setup. As Ruben pointed out before, we have similar labs on both ends, one in Germany, one in the Netherlands. And it's an EUC lab. So it's not only one machine where you run some benchmarks. So it's a little bit more complicated. You need clients, you need a host, you need a network between those two, and we're using a WAN emulator to measure what's going on in the network, number one. And number two, we want to modify the settings of the network. Introduce latency, introduce packet loss, introduce, reduce bandwidth. So this is what we are using the WAN emulator for. I have two in my lab. It's a Netropy, POSIT Netropy N60. And we're using also the Mini 2. So we all have a Mini 2. This is a very convenient device. It's not too expensive because the N60 is very expensive. It's in a range of 20K. Just to give you an idea that these devices are really expensive.
Not too expensive, still means 2K. So
Yeah, the Mini 2 is in a range of €2,000, $2,000. So this is what we're using. Sure, we have backend servers, domain controllers, file servers, all that, always the same thing. Then we are installing our test software. We have installation scripts for the software that we need to install. And we are using AutoIT to simulate user interaction. We compile the AutoIT scripts so that they include the AutoIT runtime, so that we never need to install AutoIT. And I know that Login BSI is doing the same. I don't know if you're moving away from that, but this is something that we may learn in your session. But this is what we're doing, and I know that you've done it in the past as well.
Is the RTE team intending on making community use forum around the AutoIT
Yes,
scripts?
we are going to open source the AutoIT scripts. Oh, excuse me.
Yeah.
The question was if we open source or if we publish the AutoIT scripts. Absolutely, we do.
Yeah, NVIDIA's
So
so
this is-
some of these two guys, and
Yeah.
if you're not, this is some really cool stuff.
Yeah, this is what we are planning to do because we don't see much of an intellectual property embedded in the AutoIT scripts, the things that we're doing. So it's rather good to have these out in the wild so that other people can look at them, because we need to harden them, we need to agree on what is the best method. In the end, we will compile the standard set of AutoIT scripts just in order to make sure that everybody uses the same runtime and the same script logic when we're testing and comparing the tests that are run in different labs. So that's the only reason why we want to compile them in the end. But then again, have other custom scripts where we do not distribute executables.
Yeah.
Sometimes, because if we run SolidWorks, we cannot compile stuff because SolidWorks needs to be downloaded by you anyway. We cannot distribute it, and then we can also give you just the scripts in source code, and you compile them if you want to.
Guys, this is really big, and thank you so much for you guys giving back to the community in that regards, because it helps create at least a framework of being able to commonly benchmark. We've got to get away from stopping to benchmark things, but let's see how hard we can hit things. Let's get into user emulation?
Yeah, we're working with you guys on that. So we have a lab controller PC that we're using for controlling the scripts, and we're using to record screen videos because we're using frame grabbers. Typically we use them from Epiphone. We have multiple Epiphone devices that we're using to do the frame grabbing. Basically, it's like connecting a PC, a client, to a projector. But instead of a projector, it is a frame grabber, and it just records the video, the screen videos. We started playing around with more consumer-oriented frame grabbers like the Elgato, because these are the devices that the gamers are using when they're recording their games and upload them to YouTube. So this is the thing that we're working on right now to make it even cheaper, because these are $150 devices instead of $700 to $1,500 devices that we're using today.
Have you tried Shadowplay?
Nope. Let's talk about that.
We should talk about it.
Okay.
It's also good to mention that, like in the near future, we'll also try to record like 4K, 8K resolution and multi-monitors as well, because that has a huge impact in remote protocols and GPUs.
Yeah.
So, see if we can get some time and budget available to buy that gear and do new tests on that.
Yeah, because these devices are really expensive if you want to record multiple 4K videos in real time and simultaneously.
Not to mention the hardware, the host that you have to be able to process that kind of stream.
I mean, all of it.
Yeah.
But this is what becomes more and more relevant, and yeah, we're controlling everything from the lab controller. We built a control framework for that is able to remote into the different machines and start different activities at different places, so that we in the end can correlate the data. If we are collecting telemetry data on two endpoints or on the host and on the client, we want to correlate these data sets. And this is why we need the software that controls the start and the stop of the data collection. And we record videos. Well, like Ruben said, 500 videos in the last like 4 weeks or so. So this is what we've done. And like I said, we introduce, network constraints by using the WAN emulators. So this is what we do. Now, there's one more thing that we are using in all our tests now. And this is a tool called Remote Desktop Analyzer. Who has heard of that?
Yay!
So, there's a new version of it, and it's going to be released very, very, very soon. So it has more capabilities. And thanks to NVIDIA and the conversations that we're having in Team RGE, Barry and Bram are able to improve the tool much more. And this is really interesting for us to see how this progresses. Anything you want to add to that?
Well, it's good to have NVIDIA part of that, but it's also good to have AMD and Intel in the same tool as well, so get insight what AMD, Intel, and NVIDIA are doing. And if you just start a tool, you need to have an instant view. Okay, is my GPU running? What's the utilization? What's the overall activity with the machine? That's what you need to find in that tool, and that's what you will see. I think there's a screenshot as well with NVIDIA specific. See? So there will be a new version of RD Analyzer 1.6 available somewhere in June. It's still in, well, it's a running app, so it's not a mock-up, but there's some work to do as well. And there are many conversations on the AMD and Intel side to add specific Intel and AMD support where applicable to the tool.
In terms of monitoring data variables, they don't have to have them now, right?
The good thing is now that we are monitoring the data this way, there's an ongoing conversation. Which counters are the right one? Which labels are the right one? And this was a very fruitful call that we had only like 2 weeks ago. NVIDIA and Bram and Team RG all together and well, going through these kinds of questions and answers. So that was really good. So yeah, there are new capabilities in the new Remote Display Analyzer, and we are using it throughout all our tests. So we will always see RD Analyzer running in the background, and they will add more features so that we can sort of extract the telemetry data in an even better way as we can today. Okay, now let's take a look at the video. Oh, there was a question?
Yeah, very quick question. Have you been able to test the new EDT HDX protocol?
Oh well, we had an hour in our slide deck, so don't forget to activate it. And we were both on the way to the airport, and we texted each other, hey, have you run the test? No, have you? Oh. So
we just spent 2 weeks in testing, so yeah. It's not so, it sounds yeah. Simple, just enable. No. There's a ton of work behind that.
But there is a way to deliver this information, because we agreed with Gabe that we will start producing videos that are, well, that they will publish at TechTarget under the label Geek
Out 365.
Geek Out 365. And that's the format that we're planning to put all the results into, so that it can be published through TechTarget. This is the idea that we have. I mean, if it doesn't work through them, we're going to use some other video platform so to make this information available to you guys.
This is our attempt to replace the content from Bri Forum. Even though we're not doing Bri Forum, we want to keep that content alive, and so yeah. That's our attempt at doing that. So thank you guys for helping.
This is why we're excited to keep the Bri Forum spirit living.
There's also a different reason, another reason why we didn't test with EDT, because we have the philosophy that it should be enabled by default, which is not the case in 7.13, which will be the case in 7.14. Yeah. So that's the other reason why we didn't have it.
And we didn't have access to 7.14 at this time for testing. Yeah, that was one of the reasons. But let me show you what our for-up video player turned into, because now we call it the Rex Analyzer, because it's a brand new application that we're using to run the for-up videos. It's a little bit different because you can run the videos side by side, that is one thing, but if you click on one of the videos, ooh, you can zoom into it. So we were able to really see the details, and we're using all the raw data files, no conversion anymore. So whatever video format it is, this tool is able to consume them, and we can run them side by side. Some of these videos are 100 megabyte for 45 seconds. And you run those things simultaneously, so it needs to be fast SSDs to run it. And the other thing is that we're able to inject telemetry data. These down here are still videos, so if I run those, for the first time you see Intel and AMD doing OpenGL. Wonderful. So that's on one side, it's the white label machine, the Intel from your side on the left, and AMD running in Zen server on top of the R730 is on the right side. So it works. It is comparing apples to oranges, because one is a dedicated machine and the other is virtualized. So you cannot compare directly, but performance is good, and it's about the same network consumption. If we click into it, the spikes to 9. Here the video is already finished, so we need to go a little bit back. Now we can click into it. Yeah, that's about the same spike that we see here. So it's pretty much identical. Now let's do the same again with a different test run. This test run is not OpenGL, it's HTML5. And look at that, they have a problem, they call a lookup table at AMD. Well, they've recovered, but for a while it is a problem with the color lookup table. Funny enough, Microsoft had the same problem in the past. So the water was red. We said always there was a shock in the water. But you can also see that performance here on the Intel side seems to be better, but it's stuttering. While here AMD, well, it's slow, but it's very smooth. So this is the first difference that we were seeing between the two technologies. But now, to make things a little bit more interesting, we wanted to have the shootout between NVIDIA and AMD. So NVIDIA on the left side, M60 1Q. On the other side, MX GPU from AMD with the 8 profile, so identical. Oh, let's roll the videos. And here we have OpenGL. Ooh, there's something going wrong with the OpenGL interpretation on the AMD side. The AMD folks already asked us to give them access to the script code and to the application that we're using. So, and the other thing is, you see the frame rate up here? Let me click into it, so you see. It looks like it's a much higher frame rate, but the higher frame rate doesn't help you if it sucks. Well, here it's 60 frames per second, and it's very smooth. I mean, double frame rate of garbage?
It's twice as much garbage.
Oh, it's twice as much garbage.
You just get through the garbage quicker.
That's how they do it.
What about free hypervisor?
Makes sense.
I mean, but at least for the first time we were able to see that kind of performance using AMD, so we're extremely happy that they started entering this market. Here, this is a demo where we're using the Ken Burns effect that you love so much when you are opening these typical newspaper publications in the web, because they are using all these effects that the pictures are, well, the transitions between photos and zooming into those photos. It's extremely resource intensive doing these things. This is why sometimes one browser and looking at one of these pages maxes out the capacity of your machine.
Yeah, look at the bandwidth too.
Yeah, the bandwidth spikes up to 10 megabit, 12 megabit in the LAN. But one thing that was a lot more interesting was what if...
Question.
Oh, there was a question.
No, I was, the frame rates, what was the AMD, what was the NVIDIA on the frame rates, the one before?
For the photo gallery?
Yeah.
No, we didn't measure the frame rate.
No, the one before was 120 versus 60 is what he's asking.
Yeah.
60 is just
Yeah, you cap it at...
I wanted to explain.
You cap it at 60 on the sender side because you're smart enough to send it over
Well,
to...
Citrix is capping their frame rate by default at max of 60.
Yeah.
So we put what's called a frame rate limiter, or FRL.
Yeah.
We put a frame rate limiter in place. It can be removed.
Yes, I know.
But that FRL stops us at 60.
Absolutely.
So we're overproducing frames.
What I wanted to say is here, it doesn't help you much if you have more frames per second.
Exactly.
So now we want to take a look at the CPU load that's being generated. And you see now we're feeding in telemetry data directly. On the left side again, NVIDIA. On the right side we have Intel. This was a surprising result when we were running this OpenGL thing. You see, again, very smooth on the NVIDIA side. Intel pretends to generate 1400 frames per second, but is slow-mo. And at the same time, generating a lot less CPU load, like offloading the rendering to the GPU, obviously created less overhead on the CPU, but it is by far not as efficient. So if people say that the Intel GPU is as good as the NVIDIA GPU, no, this is not true. You can see the result here. This is a machine. This is the direct connection to this machine, and still the performance is not as good as you have it here with a virtualized environment. Very interesting result here, and it was reproducible if we did yet another test and looked at the CPU load using the Ken Burns effect again, producing more load on the CPU side for NVIDIA than it did for...
What's the encoder? Are you using...
yeah. Let's have this conversation about the encoder later, because that is the critical question. Absolutely. So it is standard setting, default settings. But now we're going to do the same shootout between NVIDIA and AMD. And that changes the result, because suddenly you see AMD has more overhead on the CPU when trying to offload the heavy graphics lifting to their GPU. So they really got to do some work in order to be as good as the NVIDIA technology. That became very, very obvious here. So we're almost maxing out the CPU by only one of these browser sessions. That was amazing.
That can be driver compensation or the integration between like the driver and ACX3D Pro as an example, or both.
Now here we're doing the same thing with OpenGL, and you see pretty much the same result, almost double the load that AMD is creating on the CPU. So CPU performance, CPU clock rate is relevant no matter how good the GPU is. Do not underestimate the relevance of the CPU combined with the GPU. This is what we found out here. Good. Now we are introducing latency and packet loss, and we recorded a spectrum using only the NVIDIA technology at this point. LAN, upper left quadrant, upper right quadrant, we have 2 megabit per second limitation and 200 milliseconds latency. Lower left is 8 megabit, 50 milliseconds, and lower right, bottom right is 2 megabit and introducing 10% packet loss. Okay, let's roll the videos and see what it looks like. Here we are using an MP4 video. It's re-encoded and sent through the wire. And it's amazing how good Grid works in this combination with Send Desktop 713, except for introducing packet loss. It completely falls apart after a while. And it does not use the frame hog algorithm because it was configured standard, and it does not switch to the frame hog algorithm. So this is what users get when you have a lot of frame drops. This is very interesting for you to know that these things are happening in production environments. I've seen that a couple of times. Now we're doing the same thing with PowerPoint. And basically the results repeat. So what we find out is that reducing bandwidth is not as critical as introducing latency. Latency hurts, but packet loss hurts even more. So this is the sequence. Bandwidth is not so bad if you have limited bandwidth. It's worse if you have latency. It's much worse when you have packet loss. This is why sometimes customers are trying to buy a bigger pipe. It doesn't help them if they have latency. Aaron and I had a long conversation about that because he has a customer that is like 180 milliseconds, 120 milliseconds away. You cannot compensate for the latency, the effects that I introduced by latency. Okay, final video.
Quick question. So
can we do that at the end? I'm almost done. Please. Last one. Again, doing the OpenGL, and you'll not be surprised that it is again the same. I want to stop it here. A little bit too late. Okay. Because what you see here, you see all the artifacts that are here in this gray introduced compared to this here. It's very smooth. Here it's not, and the human eye is most sensitive for gray. Grayscales are something that we can see really well, and this is why we see that. With red, it's not the case. I mean, okay, Carl, you can't see it at all, but other people can see red. Sometimes they don't see red very well. Human beings are not made to see red color.
It's kind of weird though.
So this is what we found out. We have many more of these videos, but this is what we put together for you. But there was a question.
Yes, what do you think is the tolerable latency and packet loss? Oh,
tolerable latency, what we found out for designers is in a range of 20-30 milliseconds. Okay. So that is these are the most critical users, and I know that Frank has started testing with NV6 VMs on Azure, which use the M60 GPUs. And I think that you can confirm these things. If you go too far with the latency, not even the best GPU in the world that we have for remoting now can compensate for going across the Atlantic or going to Asia to the data centers. We cannot compensate for that, unfortunately. Yeah.
So, just a note, I think, to Citrix, and in particular, I think to Dirk Thorsland, with the HDX team. If you think that EDT can handle everything, I think the answer will probably be it cannot. So please don't give up right away on frame hop, because I think there might be a very justifiable reason to retain it.
Yeah, the thing is that frame hop uses a lot of bandwidth. That is the biggest challenge. So there's always a price for that. So it can compensate for packet loss. A lot of packet loss. We've run tests with up to 50% packet loss and it still works. But at the price that bandwidth goes up and up and up. So it
And CPU.
And CPU as well. Yeah, thank you. Okay, that was it for now. I hope you learned something new. We keep going with these experiments, building the labs and publishing it through TechTalk, and hopefully.
You had a question you wanted to lay?
That was the question that was asked, and I didn't pick. Oh, was one more?
Packet
You answered it already.
We answered it already? Oh, yeah, thank you. Okay,
Thanks.
thank you.